This video is going to cover fancy images in Matlab. We will learn how to make different types of shapes, color them in, add text, add photos, and animate. So let's get started. So if we want to make the tractor that was in the video before, first thing we need to do is find a picture of a tractor. So we'll take this picture here, so copy the image, and then we need to paste it on a graph. So you can do this by printing something out and then measuring, or you can do it on your computer. But basically, we need to be able to define points, like key points for everything on this tractor. So we will start out with drawing some axes. So we need to have an x-axis and a y-axis. So we'll just start here. So each square of the grid is going to be 1 unit. This is our x-axis. And this is our y-axis. So the next thing that we need to do is label all of the key points. So let's say, okay, we need the centers of the circles here where the wheel hubs are. So we'll mark that on our graph. So here this point is 3, and here the center of that is 3, 6, 9, 12. And then the height on here, this is also 3, and then this one height is a little bit shorter, that's probably 2.5. So then we need to go through and figure out, okay, what are the most important shapes to plot? Well, the wheels will need to have the hub of the wheel and the tire, but the wheels are best done using markers, so we just need to know the centers of those. The next shape that we'll need is the body of the tractor. So we're going to have this green part. So we're going to need every vertex. So like here, 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 so on. Basically the tips to every shape. And then we'll need this window. So here I've gone through and labeled every key point. So we've got this red box, which is going to be our tractor body. We've got the hubs for the wheels, and we've got the tires marked in the blue. And then here in the orange, we have all of the points for the window marked. So now that we have all of those points marked, then we are going to put this into Matlab. So here in Matlab, you want to make a new script. So you can either click this button, New Script, or go to New and Script. So we've got it here. So we'll just go ahead and save it. And you can see that I've already created a folder for it. I'll call that Demos. So we'll just go ahead and save. And we'll call this Tractor Code. And save that. So we are going to start out with outlining our code. So the first thing we are going to do, we'll put a title. Then we need to clear junk. We need to define points for tractor. Then we need to do the plot. Okay, so this is our basic outline, and we're just going to load things in under each one. So if we go back to here, we'll go ahead and just type in all of the points. First, we're going to go ahead here with the clearing. So clear will clear all of the workspace variables. Close all will close any open figures, and CLC will clear the command window. So that's just good stuff to put at the beginning of a script, so it wipes your slate clean. Now defining the points for the tractor. So we said before that we're going to need wheels, and then we'll need the body, and then we'll need the cab, or that window there. So we'll start with the wheels. For the wheels, we need to just define the center. So we'll say we need the big wheel and the small wheel. So big wheel X equals, and the center of that wheel is 3.5 in the X and 3 in the Y. So we'll say 3.5 in X, and then big wheel Y equals 3 in the Y. And then we'll do the same thing for the small wheel. Okay, so now that we've got the wheels, we need to do the body. So for the wheels, we just needed the centers of each one. That's because we're going to plot the wheels with a circular marker shape. That'll be the easiest way. For the body, we're actually going to have to patch the entire thing as one solid shape. So we're going to go around, and it doesn't matter if you go clockwise or counterclockwise, you just need to put the points in order. So we're going to start here at the bottom left, and then we will just go around the outline of the tractor clockwise. First, we'll do one listing all of these X components, and then we will do another one listing all of the Y components. We need to put these in an array, so we'll have 2 for the first one. So this point is 2, 3, and we're just looking at X components right now, so we get a 2 from that. We get a 2 from this one, we'll get a 4 from this one, a 4 from that one, a 9, and so on. And we'll just end it there. We do not need to close it because we're going to use the patch command, which will automatically close the shape. Then do the same thing for Y. So now we've got those points for the body. Finally, we need to do the points for the cab. So the cab here is these orange coordinates. These are a little bit harder to see, but we're going to start over here at this 4.5 and 7, and then we will go around the edges. Now we've got the cab. So the last thing that we've got to do is plot. Plot will include actually a lot of different things, but first we're going to start out with making the figure. So we'll say figure 1 and then CLF to clear anything that was on the figure, and then hold on to keep all of the shapes onto the plot. So after that, then we need to plot the body, and we're going to use a patch command for the body. So that will be patch, and then in the patch, we have to put the X points, the Y points, and then the color. So this will just be body X, body Y, and then the tractor is green, so we will just say G for green. We will get to defining custom colors in a little bit. Then we will do the same thing for the cab, and we'll say patch, cab X, cab Y, and white. And then finally the wheels. Now, the wheels, we'll do each wheel one at a time because they're not the same size. So we'll start with the big wheel, and we'll say this will be a plot. We need to put the X, the Y, and then the line specification. So we'll say big wheel X, big wheel Y, and then we need to put some, so we'll say KO, because that will make it a circle. The O means a circle marker, and then the K means a black outline. But we also need to fill that in. So let's say the tire is black and the hub is yellow. So we're going to plot the tire first and then the hub because we want the hub to show up. Otherwise, basically the tire is actually going to be a full solid black disc, and we need to plot the hub on top of that so that it looks like the tire is a ring. So we've got the big wheel X, the big wheel Y, KO, and then we'll say to get the actual tire color, we'll fill that in with marker face color. And K for black, and then marker size. which the size is extremely arbitrary. So basically a bigger size is a larger marker and a smaller size is a smaller marker. This totally depends on your computer. So I'm just going to go ahead and put something and then, so we'll say maybe 130. And if for some reason that ends up too big or too small, you can just change that value. Okay, so this got the tire, and then we have to do the hub. So we'll plot the same thing, except instead of making the face of this one black, we'll make it yellow. And then we will shrink the size of the hub because it's smaller than the tire, and we'll say 70. Okay, so now we need to do the same thing again for the small wheel. And let me get small wheel. Okay, and then we'll go ahead and set axis limits. So for the axis limits, we'll have the X limit. So the X limit is going to have a bracket, and what goes in there is the lower limit and the upper limit. So maybe let's make the X axis go from 0 to 20, and the Y limit from 0 to 15. Now, I chose these basically because the biggest number that I see here of all of the points that we got is 15. And looking at this grid, if we plot from 0 to 20, that should give us plenty of space. And then in the Y, 0 to anything greater than 10 should also give us plenty of space. So we'll go ahead and run this code. Okay, so we've got this tractor. So the wheel might be a little bit big, but you can always adjust that. So a couple of things that we can see here. It's not exactly accurate, which obviously it's not going to be, but we can make our colors more customized. So let's say we want these tractor wheels hubs to be a little bit more golden than to be yellow, and then we want this green to be a darker green, closer to that John Deere green color. So the easiest way to do that is just to look up the RGB values. Now in Matlab, you can actually specify certain RGB values. So Matlab specifies it between 0 and 255 divided by 255. So a scale of 0 to 1. And you normally when you see RGBs, they're listed between 0 and 255. So basically, you just have to scale those down between 0 and 1. So let's say for the cab that instead of doing white, maybe we want to do gray. So we'll take away this W here. This is the color spot. And gray is just going to be equal values of all of the colors. So we can say now maybe 0.5, 0.5, 0.5. Okay, so I'm going to run that. We see it popped up here. So that gray is a little bit dark. 0.5 is halfway between 0 and 1. If we make it a little bit closer to 1, maybe say 0.7, then that will be a lighter gray. So we'll just do that. All right, so we've got that lighter gray, but we still need a darker green and a darker yellow. So let's go and figure out what those RGB values should be. Okay, so if we just, the easiest thing is just to Google it. So we'll say RGB green. And here comes up with some green. So maybe we'll go with this forest green, which says 34, 139, and 34. So let's plug that in here. So instead of this G, we'll put a bracket, and then we'll say 34, 139, 34, and then this we have to divide by the 256 to get it between 0 and 1. Okay, and these actually, it looks like they're between 0 and 255, so we'll just go ahead and divide by 255. Okay, so that should get us green. We'll run that. Okay, much better. And now we need to do the yellow. So we'll just say here, I'll go with gold because that's a little closer to what we want. And we'll go here and see what do we want. Okay, there's gold and there's golden yellow, which I think the golden yellow is probably a little closer. So we'll choose that one. And here, we'll put that in right here where we have this yellow. And we'll say that's going to be 255, 223, and 0. And then again, we have to divide this by 255 to get it scaled properly. So we'll take that and we'll put that here as well for the other. We'll run that. Great. Okay, so going back to our actual photo and then our plot, we can see here, this looks much closer to the tractor. Now the wheels do still seem a little bit big, but what we can do for this is we can also scale the size of our plot window. So maybe we want our plot window to be a little bit bigger than the size that it is now, and maybe instead of popping up in the middle all the time, we want it to pop up over on the left side. So we can set the figure position. So if we go over here to where we called out the figure, after the CLF, we need to set the position. So I'm going to say set position. And for that, it is set GCF, which means get current figure. And then we tell it position. And then we need a bracket that has 4 things in it. So this bracket is going to have the X and Y coordinates of the bottom left corner, and then the width and height in pixels of the object. So X and Y coordinates of the bottom left corner, and this is going to be in pixels. So you have to kind of experiment depending on the size of your particular computer screen, but we'll say here that maybe it's 50 pixels in the X. That'll get us close on the left side, starting from 0, 0 in the bottom left corner. So maybe we go over by 50 in the X and then maybe up by 300 in the Y to kind of get in the middle. And then we need to say how wide is it in pixels. So maybe if we go 600 wide and then 400 tall. We'll run that and we'll see what it does. Okay, so you see it popped up here over on the left side. Now that is still kind of a little bit small. We could maybe make that bigger. So I'm going to make it a little bit wider here at 700 and then a little bit taller at 500. And then you see now it has grown, except that the markers did not change size. So that's something to be aware of. The markers do not scale with the figure size. So if you're changing the size of your figure, your markers will not grow or shrink. Okay, so now that we have set our figure size, then we can start to get a little bit fancier with this. So say we want to load in a picture. So if we want to load a picture into Matlab, we need to first find the picture, put the picture in the appropriate folder, and then add it into our figure. So let's find, say if we want a picture, like we want the tractor to look like it's actually on a farm. So we search for farmland. There's all kinds of different photos, but this looks like a good one. So we will save this. So right click and copy or save image as. So let's go to our demos folder and we will call this farmland. Now make sure it's a JPEG or a PNG or some kind of like actual picture or photo type of file. So we'll say farmland, save that. So now we'll go back to Matlab. And here in the command window, you can see that farmland has showed up there. Now this ASV, we don't need that. It's not hurting anything, but we don't need it. So farmland is in there. Now, how do we actually get that into the plot? Well, we can add it here. So right after the hold on, we want the photo to be in the background. So that needs to be plotted before anything on the tractor is plotted so that it shows up first and everything else gets plotted in front of that. So here we'll say load picture. Okay, So the command to load it in, first we have to read the image and assign it to an object. So the reading image command is called imRead. So we'll say photo equals imRead. And this is where we put the actual name. Whatever you called it, you need to type it exactly like that. So we'll say farmland.jpg because we saved it as a JPEG. And put a semicolon after that so you don't get junk in your command window. And then to make it appear, the command is imShow photo. And then a lot of times you have to put hold on again after that. Sometimes it'll erase stuff. So we'll just put the hold on there just to make sure. Now, this isn't actually going to work perfectly, but I'll run it and show you what that does, and then I'll show you how to fix it. So if we run that, we saw that picture flash for a second, but now all we see is blue and our tractor is upside down. So this is a common issue when you're first trying to figure out how to load pictures into Matlab. So we're going to go through, I'm going to step through the code and show you what's actually happening here. So, all right, so we run to this point. So there it goes, we step. Okay, so now we hold on and now we assign the photo and then we show the photo. So there is the photo. So that looks all right. So now watch what happens as we step again. That patch, this was the body of the tractor. Where is that? Well, it's actually this teensy little thing over here in this corner. It shows up that tiny because the picture is scaled in pixels. It's like already whatever size in pixels that it was, that's how much space it's taking up. The axes on the plot have not been set. So then when we do set the plot axes, it crops it down to a tiny little corner, this tiny little corner here. So if we go ahead and we'll just look at that, mouse over, it says this is 801 by 501. So what happened is this picture shows up and it's 801 wide and 501 tall, and our tractor is only like 15 wide and 10 tall. So that's why it shows up so puny over there. Okay, now, so I'll show you that as we keep going. So there it added the cab, and now watch this. Okay, so the wheels are showing up extra big because again, the size of the wheel marker does not scale with the figure. Okay, and so then we set the X limit, we set the Y limit, and now suddenly we're zoomed in on that top left corner of the photo. Now, also the tractor's upside down, so that's a whole separate issue, but first let's fix this scaling. Okay, so instead of the imShow for the photo, we're actually going to scale that image down to the size of our plot. So I'm going to comment that out, and instead I'm going to say image SC, that stands for image scale. And then here we have to set brackets with the X limits, brackets with the Y limits, and then the photo. And then again, we'll put that hold on. Okay, so the X limits we have down here were 0 and 20. So we'll put that in here, 0, 20. The Y limit we had set to 0 and 15. So we'll set this to 0 and 15. Okay, so if we run this now, so it did show up, it is appropriately scaled to the size that we need. However, it is upside down. Now this time it's the photo that's upside down instead of the tractor, but either way there's a problem. So it is weird. That is how Matlab does it, but in order to make it show up properly, we have to flip it upside down. So that command is the flipUD command. So we'll go in here and right here where we had the photo, we're going to flip that. So it goes flip UD parentheses, put that photo in there, and then close parentheses. That will flip it upside down. There's another command, flip LR, that'll flip it between left and right if you want mirror image. but we'll go ahead and just run this. So there, now we have the tractor in front of the farmland. So this is great, but there is a little bit more that we can do with this. So let's say that we want to make maybe the edges of this window rounded. So maybe we don't want it to be like exactly, such sharp corners because that's not how the window is. So let's look back at the here. Okay, well, it's kind of hard to tell in the photo, but generally, like, say we want to make those corners a little bit rounded. What can we do there? We can get a little bit fancier with our cap. So I'm going to comment this out. Instead of the patch, we're going to use what's called a poly buffer and a poly shape. So what we do here is first we have to assign an object to this shape. So we'll go ahead and call that object cab. This basically just means that, yeah, we just need an object that we can then use in a calculation or inside of a function. So this cab will then be the input to a new function. So we'll say cab equals, and then the commands to type are poly buffer, and then parentheses poly shape. And then we will go ahead and put in the cab X, cab Y, and then the color. So we'll say, oh no, just cab X, cab Y, and then the roundingness of the corners. So we'll say 0.5. It has to be between 0 and 1. So we've got that, put a semicolon at the end, and then we'll plot that shape. So we'll say plot cab, and this time there's no X, Y, that's already taken care of, just plot cab, and then the face color, and then we had used all 0.7, so we'll just put that in again. And then that we'll do like that. Okay, so we run this. Oops, we got an error. Okay, X, Y coordinate matrix must have 2 columns with at least 3 rows. Okay, so the problem here is that this parenthesis on the end is in the wrong spot because it will take that one away, and that poly shape needs to have the cab X and the cab Y in a parentheses, and then close that parentheses, and then have the comma, and then the poly shape and the 0.5 are in the parentheses with the poly buffer. So we run that. There we go. All right, so it looks like that might be a little bit large for corner rounding. So I'm going to go ahead and shrink that. We'll say that 0.2 instead of 0.5. And if we want to compare it to the one, well, so I'll run that. Okay, so we got that. Now, to compare that one to the one before, we can actually make this a little bit transparent. We can replot. So we'll plot our original one here. This was the patch. And then we'll have our new one with the rounded corners. So we run that. And there you go. You can see that the cab, you can see the old one, which is the gray, and you see the new one here. And if you want it actually to be a little bit more transparent, you can put in something called a face alpha. A 0.5, we'll run that. This changes, face alpha is a transparency property. So if you want to make it more or less see-through, then you can do that. So we'll run that. And that looked fine, so we'll leave it there. Okay, so we've got now window with curved corner, some transparency. And now what we can do to make this a little bit more fancy is let's add a title here. And we'll put the words actually in the plot. So to do that, to add text to a plot, the command is pretty easy. It's just text. So we'll say text and we'll say, so the command starts out text, open parentheses, and then you want to put the XY coordinates of the bottom left point of your text. So wherever your text starts. So let's say maybe we want it to be at like 4 in the X and 11 in the Y. So we want to start our text like right there. We'll say 4 in the X, 11 in the Y, and then in quotes, we put the text that we want. So let's just say, my big green tractor. So if we run that, there it showed up. So that's nice, but we can make it better. It's a little bit small. So there are some other things we can add. We can make it bold, we can change the size, we can change the font. There are a lot of things that we can do with that. So I'll go ahead and show you how to do that. So we'll say to make it bold, we change the font weight. So font weight and then bold, just like that. To change the size, you just set font size, and maybe we'll go with 20. And to change the type of font, there's font name. So this one is probably Arial. Matlab has a lot of different fonts, but we'll go with Times New Roman. Put that there. So now, so that got a lot bigger, looks a little fancier. It might be a little bit low, so let's move this up to 12 or maybe 13, just to get a little higher in the sky. Okay, so there you have it. So this is the static plot. So up next, we will do the animation. So next we want to make it look like the tractor is actually moving across the screen. In order to do that, now that we've got a whole set of points, all of these points we had statically defined as just specific X and Y coordinates. So what we need to do is make this entire coordinate frame move from one side of the photo to the other side. So currently the coordinate frame is situated at 0, 0. So that's the starting position. So what we can do is define a changing variable that starts at 0 and then goes all the way until x equals 15 or whatever, how far it needs to get this tractor off of the screen. So all we need to change is the x position. We don't need to change the y position because then the tractor would be floating. So we're just going to change the starting position x, and that will make the tractor look like it's moving. So we have to put this in a for loop in order to animate. So I'm going to go back up here, and we will say for maybe frame equals 1 to however many frames that we want, maybe 40. Let's see. Actually, we'll do more than 40. We'll go 70 frames. So we start that for loop here, and we're going to go ahead and end it down here. Okay. So now this whole thing is inside of a for loop. Now the photo, the actual background photo doesn't need to change position, so that's all good. We'll leave that. The only thing that needs to change position is the X coordinates for everything, for all of the tractor parts. So we are going to start out with defining a position. So let's say our starting position, wherever we want the tractor to start, and we'll make this starting position, say equal to -15. And I'm choosing -15 because this tractor is 15 units wide. Basically, it starts at 0 and it ends at 15. So if our starting position is -15, that means the whole tractor will be out of the picture when we start. So position is 15. Now, as the frame goes through all 70 frames of the animation, we need to change that position. So we'll say that position equals position +1. This is how far the tractor moves with each frame. So we'll set it at 1, and then if it turns out that that's too fast or too slow, we can make an adjustment. Also, this frame's we might need to make an adjustment there. So we have position equals position plus 1. So now what we're going to do is we're going to go ahead and add that position variable to all of these x coordinates so that they all will move together. Just the x coordinates, remember, not the y coordinates. Okay, so now we've gone ahead and added that. And so now let's run that and see what happens. Okay, so that might be a little bit fast. We can slow that down. Let's say position plus 0.5 and run that. Yeah, so this is much better. And there you have it, an animated tractor going across the screen. So this is all that you need to get started with fancy animations in Matlab. So go ahead, if you have any questions, you can post them below, any comments or anything cool that you learned, please share that with everyone.